Hi, this is problem number 7 and moment of inertia. Here it is asked to find moment of inertia and radius of gyration of the area about the base AB and the central axis parallel to the AB. Let me draw the central axis and reference axis. First I will draw the reference axis. This is reference axis 1 and reference axis 2. Okay. Let me draw the central axis as well. So this is what? This is central x-axis. Okay. So in the question, it is asked to find moment of inertia and radius of gyration about the base AB. Okay. Means we need to find IAB and KB. Means radius of gyration about the axis AB, KAB, IAB and KAB about the base AB and central axis parallel to AB. Which is the axis which is the central axis which is parallel to AB? X-axis is the axis which is parallel to the AB, correct? So which means we have to find IXX and KX. Okay. To find radius of gyration and moment of inertia about AB and radius of gyration and moment of inertia about an axis which is x-axis which is parallel to AB. Okay. To find this IAB, see whatever the moment of inertia about axis 1 no, the same value will be there for moment of inertia about AB. Okay. Whatever the moment of inertia about axis 1 you get, the same value will be for moment of inertia about AB. I11 is equal to IAB. Means which you have to find moment of inertia about axis 1. Okay. If you know moment of inertia about axis 1, it will be equal to IAB. Then to find KAB, it will be root of IAB divided by A. Okay. So to find moment of inertia about axis 1, we have the formula here. Okay. Sigma IGX plus sigma AY square. Means we have to find area values, Y values, AY values and AY square values, and IGX is also needed. IGX is also needed. By this we will get moment of inertia about axis 1, which in turn equal to moment of inertia about AB. Okay. Knowing moment of inertia about AB, you can find radius of gyration about AB. To find this IXX, we have a second formula here. So using this second formula, we can find the IXX. Knowing IXX, you can find KX, radius of gyration about x-axis, the root of IXX divided by A. Now, initially we will find I11. To find I11, we need to calculate all these parameters: area, Y, AY square, and IGX. Okay, here I written the table which includes all the required parameters. Okay, so here in this figure we have only two components. One is triangle and second component is rectangle. Okay, so in the problem it is asked to find moment of inertia and radius of gyration for the shaded area. Actually it is not mentioned in the question to find the moment of inertia for the shaded portion, but by default it is understood. Okay, if an unshaded portion is given, so you have to find the moment of inertia or the radius of gyration only for the shaded portion only. Okay, here we have this rectangle which is unshaded portion, so we have to deduct area of this rectangle while finding the total area, and while finding this IGX values also we should take negative sign. Okay, even if it is not given in the problem, to find moment of inertia for the shaded portion, if shading is given in the problem, means if there are some unshaded components in the problem, it is by default it is understood. You have to find the moment of inertia or the radius of gyration only for only shaded portion. Okay, let me write the units. Here it is mm square, millimeter, millimeter cube, millimeter to the power of 4, and millimeter raised to 4. So I'll divide this whole figure into two components: triangle component number 1 and rectangle component number 2. Okay, then here you need y values, no? Let me write the formula for y. See, for rectangle it is d by 2 from its base. For rectangle it is d by 2 from its base. For overall triangle it is b by 3 from h by 3 from the base. H by 3 from the base. Okay, I'll take the first component now. First component is what? Triangle. Overall triangle component number 1. Area is half into base into height. Okay, which is equal to half into base width of triangle is how much? It is 40. Here it is 20 mm plus 40. So overall base width of the triangle will be 100 mm. Okay, and overall height of the triangle 30 plus 30 plus 30, it is 90 millimeter. Overall height of the triangle is 90 millimeter. So 100 into 90. 100 into 90. Answer for this is 4500 mm square. Coming to the y value for triangle, we know the formula, that is h by 3. Height is 90. Divided by 3, you will get 30 mm. So AY, if you calculate, it is 1,35,000. AY square is 4.05 into 10 power 6. IGX formula for triangle is, we know that it is BH cube divided by 36. BH cube by 36. 100 is the base width, 30 is the height, cube divided by 36. The answer is 2.025 into 10 power 6. Please cross check your answers. Then the second component is rectangle. Rectangle component number 2. Very important, take negative sign because it is unshaded portion. B into D. B into D. Width of rectangle is 20 mm, depth is 30 mm. Minus 20 into 30. The answer is minus 600 mm square. Coming to the y value for rectangle. Okay, means distance of centroid of rectangle from reference 1 axis. This distance. This is the y value for rectangle. From its base it is d by 2. Okay, from its base the distance of centroid of rectangle is d by 2. But from reference 1 axis it is 30 plus d by 2. 30 plus d by 2. Okay, so I will use the same formula here. 30 plus d by 2. 30 plus depth of rectangle is, it is also 30 mm. 30 by 2. The answer is 45 mm. 45 mm. AY is minus 27,000. AY square is minus 1.215 into 10 power 6. IGX formula for rectangle, we know that it is BD cube by 12. And very important, negative sign. Okay, because it is unshaded portion, negative sign. So minus 20 into 30 cube divided by 12. The answer is minus 45,000. Okay, minus 45,000. So here we have only two components. So let us calculate the summations. Total area is 3,900 mm square. Sigma AY is 1,08,000. Sigma AY square is 2.835 into 10 power 6. then sigma igx is 1.98 into 10 power 6. Okay, now we will use the first formula. I11 is equal to sigma igx plus sigma ay square. I11 is equal to sigma igx plus sigma ay square. Sigma igx is 1.98 into 10 power 6 plus sigma ay square is 2.835 into 10 power 6. The answer is 4.815 into 10 power 6 millimeter raised to 4. Okay, moment of inertia about axis 1 is nothing but it is moment of inertia about AV only, base of the triangle only. Okay, therefore you write here IAB is equal to moment of inertia about the axis AB. Okay, it is asked to find about AB now. AB is equal to moment of inertia about axis 1 is equal to 4.815 into 10 power 6 millimeter raised to 4. This is moment of inertia about axis AB. It is also asked to find radius of gyration. Radius of gyration about AB, KAB is equal to root of IAB divided by A. Moment of inertia about AB is 4.815 into 10 power 6 divided by total area is 3900. 3900. The answer is 35.13 millimeter. 35.13 millimeter. Okay. To this, finding radius of gyration and moment of inertia about axis AB is over. There is one more question to find radius of gyration and moment of inertia about the central axis parallel to AB, means Ixx and Kx we have to find now. Okay, to find Ixx we have to use the second formula. I11 is equal to Ixx plus A into y bar square. I11 is equal to Ixx plus A into y bar square. I will rewrite this formula as Ixx is equal to I11 minus area into y bar square. So we need y bar here now. Y bar is equal to sigma ay by sigma A. Sigma ay is 1,08,000 divided by 3,900 is the overall area or the total area. By this y bar that you get is 27.69 millimeter. 27.69 millimeter. Therefore, substitute in this formula. In this formula, Ixx is equal to I11. Just now we have calculated it. It is 4.815 into 10 power 6. 4.815 into 10 power 6 minus total area 3900 into y bar 27.69 square. By this we will get moment of inertia about x-axis, that is 1.824 into 10 power 6. 1.824 into 10 power 6 millimeter raised to 4. Okay, now you can find radius of gyration about the same axis. Kx is equal to root of Ixx divided by A, which is equal to root of Ixx is 1.824 into 10 power 6 divided by overall area 3900. Therefore, radius of gyration about x-axis is 21.62 millimeter. 21.62 millimeter. Okay, so this completes the solution of this particular problem. If you have got any doubts in any of the steps, you can post your doubt in the comment box. Okay, thank you.